think this is the most important section to understand how SSE works, essentially, right? Or at least this particular implementation of MCP server works. Every time a call is being made, for example, if you see when the SSE endpoint was established, you saw that there is a connection was established, and we also established a session using the session ID here, and it has sent out the acknowledgement. And what it has done is basically this is what it has returned. The response from the LLM is this. The object is tool, and it has identified the tool name correctly, which is time tool, and it has also created the argument and the variable correctly. So and what it has done is basically this is what it has returned. The response from the LLM is this. Hey guys, welcome back to the channel. My name is Zahir, and today we'll be implementing an MCP server that uses server sent events as a transport. We'll be writing a custom client to talk to the MCP server, and we'll see how that is implemented. We'll go into the depths of understanding the server sent events and how it was implemented in MCP and how you can leverage that in your projects. This is going to be a crude implementation, not production ready, but this should give you an idea of how you can implement this in your projects and essentially build on top of that. The first thing that we look at is what are the libraries that we need. So let's go to requirements.txt. We obviously need MCP here. We need OpenAI as the LLM, essentially OpenAI's SDK to communicate with the LLM. I'm using GPT-4o Mini as the LLM here. We need Fast API as the framework to create a web API, because essentially we'll be, though we'll be using local host, but you can imagine that application to run in maybe some server on a cloud, and you use that URL to essentially communicate with that particular application where your tools are running, right? We'll talk about it. You'll understand what I mean. And there are standard packages to essentially make your application work. This is the server class, MCP server underscore SSE.py. I'm importing a few libraries here. I'm obviously importing Fast API because I need to create a Fast API application. Zone info to essentially, now that I realize this, actually you don't need PyTZ because I think we solved this using zone info, so you're good here. Let me go back to this. I'm sorry, let me go back to server SSE. Yeah, let's focus on server SSE now. Let's focus on some of the modules that we haven't seen before. We are using Starlette. Starlette essentially is an ASGI server. ASGI stands for Asynchronous Server Gateway Interface. In fact, Fast API is built on Starlette, so you can imagine how robust Starlette is. So it's a server, and we'll be using some features of Starlette to essentially enable an SSE server. Okay, SSE is basically server sent events. It's a protocol to essentially establish a one-way communication between the client and the server, where once a client establishes a connection with the server can continuously send streams of events back to the client, right? I'm gonna talk about SSE in a bit, but let's move on to some of the other imports that we have. Obviously, we'll be using MCP here. There is the Fast MCP class to essentially instantiate the server, and also the SSE protocol itself. In SSE, that is the SSE module will import SSE server transport. This is the transport mechanism that we'll be using to connect the client and the server and to establish the two-way connection, or at least have a workaround for a two-way connection. Hold on to that particular thought. I also imported LogGuru, as you saw. But in this particular example, we'll be using logging, the simple, built-in logging module. All right, let's get to the important parts now. This is how we instantiate the server, as you had seen in the previous BMI server video. Essentially, we create an instance of Fast MCP class, and we pass the name as the parameter here, or the argument. And the name of this particular MCP server is weather and time SSE server. That's what I have named. I'll move on to the tools now. Essentially, once you instantiate the MCP server, you need to create a decorator that is mcp.tool to essentially use the underlying methods as a tool. Now, there are two tools here that I want to use as part of the demo. There is the time tool and the weather tool. Time tool essentially tells the time for a given time zone, and the weather tool, as a simple example, returns the current weather for a particular location. Very simple implementation, as you can see. All right. I have two tools for this particular server. Now here's where the important parts start. You guys to pay close attention to this particular section. I think this is the most important section to understand how SSE works essentially, right? Or at least this particular implementation of MCP server works. All right. So we are defining. Let me scroll down a bit before I talk about handle SSE. It's important to understand this particular method. Remember, we imported the Starlette ASGI framework. It's essentially a server. We are instantiating that server. What Starlette is basically it's a lightweight ASGI framework. It is meant in this particular case to handle the SSE transport endpoints for our MCP server. That's what we wanted to do. Okay. Now let's look at this line by line. All right. So we have created this application that is a Starlette application, and we are defining two routes here. One route is basically we make a GET request on the SSE endpoint. This is where the client, now we'll write the client in a bit, or I'll show the client also in a bit. This is where the client establish a persistent streaming connection to receive events from the server. Remember, SSE is a protocol where a client establish a permanent connection or a persistent connection rather with the server, and the server, after the connection has been established, continuously sends streams of events back to the client. That is why we need this particular endpoint. And if you see, once this particular endpoint is invoked by the client, we then also, this in turn, in fact, invokes this particular method, the handle SSE method, right? We'll come back to the handle SSE method in a bit. We'll talk about the messages endpoint. Now we are mounting the messages endpoint here. This is where the client sends JSON-RPC request and messages back to the server using HTTP post method. As you can see, remember, we need a way to communicate with the server, right? We need to essentially establish a connection, not just to receive events, but also send events now or send queries to the server. This is where we use this SSE to establish a permanent connection or a persistent connection rather, and messages to essentially send messages to the server. All right, that is a client sending messages to the server. I think you're good so far here, right? Now let's look at the handle SSE part here. This is a handler function for the SSE GET request, right? This is when a client initiates a connection to the SSE endpoint. That is this particular endpoint, right? So essentially what we are doing here is the MCP needs two asynchronous streams. One is basically an in stream and the other is an out stream. In stream here is essentially to receive messages from the client, as simple as that, right? This is part of the MCP protocol where it is using the in stream endpoint or in stream asynchronous stream to essentially receive messages from the client, and outstream to send JSON-RPC responses and events back to the client. Let me quickly show you what I am talking about here. If you go to the official documentation, this is the transport mechanism, and this is the JSON-RPC protocol and structure that it uses. This is how it is sending request, and this is how it is essentially sending. This is how it is getting requests, and this is how it is sending responses. I'm talking about the MCP server here, right? You can go through the documentation. I'm going to add that link in the description. But let's get back to this particular section here. Now, why do we need these streams? While SSE is technically, one way, that is a server to client communication where the server is continuously sending streams of events. In MCP, we emulate using the in-stream and out-stream asynchronous streams, a two-way connection. SSE for server to client JSON-RPC and HTTP post for client to server JSON-RPC request, right? So that's why we need these two streams. So if you pay close attention to this MCP server.run here, the MCP server takes over, right? And it enters an event loop here. It listens for JSON-RPC request in the in-stream, in the in-stream object here, which is basically receiving the messages from the client. The client is essentially making a post call using the /messages endpoint that we saw here, right? And this basically the server processes that request according to the MCP spec, whatever spec that you've written, and the JSON RPC requests and notification are sent out by the server using the outstream asynchronous stream object. All right. And this particular method, that is create initialization options, essentially initiates capabilities and options specific to the connection, like the tools that we are supporting and the protocol version and the prompts, everything, etc., etc. All right. I hope this was clear. Now, once we have established this, that is, we've created a Starlette application by passing the route and the other route by mounting the other route, that is messages. We will then mount this particular application to the default route, that is the fast API application that we have just created, as you can see. You can ignore this part. We don't need this. This is just to establish a health check. We'll be running this particular application on port 8100. All right. So while we look at the client is going to be very simple. Let's actually start this particular server. So I'm going to type a simple command, Python MCP underscore server underscore SSE.py. I'm hoping I'm in the right directory. Yes, I am. And within a few seconds, we should see the server running. All right, we have the server up and running now. Let's look at a simple client to communicate with the server. Okay, I've written the code already. The code is very similar to something that we've already seen. That is something that we established in the previous tutorial here, BMI client. The only difference here is that instead of the STDO client, we'll be using an SSE client here. That's the only difference here. We're still using the client session, but the client here is the SSE client, a built-in client that is written in the MCP package. Okay, that's the only difference you need. I'll quickly walk through some of the things that we need here. We've written this LLM client to essentially communicate with OpenAI's LLM, in this case GPT-4o Mini. This is the system. This is the role that is the system message, and we'll be passing the user message as a prompt here. Simple implementation. All right. I'll come back to the prompt here, but this is we'll be using this prompt by passing some context to it. That is query in the tools. And the prompt looks something like this. I'm not going to spend a lot of time here. You've already seen that. But let's talk about this particular part now. To essentially communicate with the SSE server, I need to do two things. One, I need to first instantiate the SSE client that we have seen already. And if you remember, we'll be communicating with the client with two streams, right? One is the in-stream to send out events, and the out-stream to essentially take the events from the server, right? And we'll be the URL of the server is this, right? I'm obviously running this in localhost, and as you saw, the port is 8100, and the default endpoint, or the endpoint where the connection will be established, is /SSE. It could be whatever that you want to define in the server, but as you saw, we had defined this as, let me actually open this in a new tab here. I'm sorry. Spread to the right. I'm going to close this. Oh, yeah. I'm going to split the server to the right so that we can focus here. Okay. We scroll down a bit. I know it's a little distracting, but this will be help us, establish the context. So if you pay close attention, I'm establishing a client. I'm passing the URL because that's the port that I have, started in the server. As you can see, it's running on 8100. And if this is running on, maybe some cloud, then the URL will be completely different, as you can imagine. All right, so we are using the with statement to essentially create a context of the SSE client. And within that, we'll start a session, the client session. This is again part of the MCP package. And it'll use the in-stream and out-stream stream objects to essentially maintain a session. Once the session is initialized, we will get the list of tools by just calling session.list_tools. All the tools are defined here in the server, as you can see. There is the weather tool and the MCP tool, and all of these tools are called here. We need the tools because the entire premise of this particular MCP server is that I can essentially work with tools or work no matter what tools have been abstracted by the API. I get to work with those tools. Essentially, that's what I'm using this. I could use a simple stdio by using a file, but here, because I'm running this through, I'm running this on a network, I need to essentially, use this particular URL. But essentially, we get the tools here, and we pass the tools and the original query that is coming in from the user. The query is here. There are a list of queries that I'm going to run in a bit, but the query is coming here, and what we do is we generate the prompt. The prompt is written here. I'm passing the query and the list of tools. Now, let me move this to the side a bit. Now, list of tools is an important concept that we need to understand. Remember, the LLM obviously doesn't understand what MCPs are, but it can basically, given the context, it can help you make some decisions. So I'm passing a list of tools here, and depending on the query, that is the request, the kind of query that the user is asking, I want it to select the appropriate tool. So what I'm doing is I'm iterating over the list of tools, and I'm using the tool name, description, input schema. I'm sending as much context as possible to the LLM, and essentially passing that as context. As you can see, I'm using a join method to essentially join both the tools or the list of tools here. In this case, there are two tools, weather tool and the time tool. I'm passing that as the context, and I'm asking the LLM to essentially decide which is the appropriate tool and return an object that looks like this. There's a tool name, and the argument, whatever arguments that particular tool needs. How does the LLM know what arguments, what is the parameters that it needs to send? It needs to send. So this particular input schema essentially will tell everything. You will see this, the input schema, when I essentially run it now. All right, that's all there is to it, right? Once the prompt is sent to the LLM generates a response. It'll generate a response in the object in the format that we just saw. What we then do is we pass two key parameters or arguments to that an important method to execute the tool. So let's say that if I wanted to see the time, then let's assume that the LLM has identified that it is the time tool is the appropriate tool to check time. Then what I do is I capture that response from the LLM in the tool call variable and pass the tool name to the call tool method in the SSE client session that we have just established, and the arguments that it has created. In this case, it is just taking one argument, which is basically an input time zone, and we generate the response. I'm not returning the response. I'm simply essentially printing or logging the response from the LLM and the tool. Okay. So I have two queries here. The queries are what is the time in Bengaluru and what is the weather like right now in Dubai. Okay. So let's create a new command prompt session. And we will essentially start that particular. Yeah, this is good. We'll start the client now, Python MCP underscore client underscore SSE.py. Okay, so I'm going to run this. Remember, there are two queries, and I need to see the response for these two queries. All right, so let's run it now. Okay, I got the response already for the first one, and I have the response for the second one. Let's quickly see some important, log statements. Let's go back from the beginning. All right, so as you can see, it was able to connect to once we started the client, it was, because the server is already running, it was able to establish the connection with the server. Let me actually show you the server as well. And as you can see, every time, let me go back to this. Every time a call is being made, for example, if you see when the SSE endpoint was established, you saw that there is a connection was established. And we also established a session using the session ID here, and it has sent out the acknowledgement, as you can see. And if you see some of the messages that we sent here, in this case, the MCP server processing request of type call tool request, it got a message the input variable to be Asia Kolkata for the tool that has been printed as well. But let's go back to the client. All right, so I spoke about the tool input schema, right? It is right here. Let me show you that. Yeah, so this is the tool. We get this after we initialize the session, and we have established the connection. We've initialized the session. We get session.list of tools, essentially gets a list of tools, and the list of tools is basically this. Tools, there is a tools object here. It has a list. It's a list object essentially, and it's a, if you can see here, there is tool which has a name, description, and the input schema here. Here it is. And the input schema is essentially telling us what is the kind of property that or the parameter or arguments that it requires. So the name of the property here is input time zone, and the type is string. That's all we need to understand. So the number of tools you have, all of those tools can be logged in. You can check out what does the input schema look like. All right. Now the other important part here is the prompt itself. And the prompt was composed. We passed two critical information to that. One is basically the list of tools, and the other is basically the user's query. Now the user's query is what is the time in Bengaluru, and this is the prompt that we are telling it. And what it has done is basically this is what it has returned. The response from the LLM is this. The object is tool, and it has identified the tool name correctly, which is time tool, and it has also created the argument and the variable correctly. So the variable is input time zone, and the input is a time zone Asia Kolkata, obviously, because I'm asking for the time in Bengaluru, right? That's what I think I'm doing. Yeah. All right, so once that was done, user query, this is the response. I've logged the response. What is the time in Bengaluru tool response? The current time is today's date, followed by it is 12:41 in the night. All right, then it has more. I'm basically iterating over here, as you can see. It was able to make a connection again. I'm obviously, this is a very crude way of writing this. Ideally, you don't have to establish the connection over and over again, or maybe you should for security reasons. But what we are doing here is, because for the second query, I'm simply restarting the entire main method, obviously. So uh, it was able to establish the connection once again. It is printing all the tools. And this time the query is, what is the weather like right now in Dubai? And let's see what the response is. And let's see if it has identified the tool as expected. Let me scroll down. Yeah, let me scroll down a bit. The tool is correct. It's the weather tool, and the location is Dubai. That's the argument for the particular tool. And the response is perfect. What is the weather like right now in Dubai? Tool's response is the weather in Dubai is currently broken clouds with a temperature of 33.52 degrees centigrade. All right. I think we have established this really well. Okay. Now let's add some complexity. I'm going to clear the screen. I will still keep the client connection on. Now let's use a chat format to essentially chat with the MCP server. And the MCP server that we'll be chatting with is going to be the same one, which is basically the SSE MCP server that we just did a walkthrough about. Okay. The reason also I have created this chat example is because I want to show you how it is able to, just like an agent would. Some of the examples that I have seen, if you have been following my channel, I've created a custom agent using the same example of a time tool and a weather tool. I want you to understand how you can actually establish a little bit of memory in a chat-like interface, a chat-like client, and use that to your advantage to communicate, or have a conversation with an MCP server, or work with the tools essentially by giving it multi-ton queries. All right, so I'm going to quickly walk you through the code here. I've created a class called S. Okay, let me take a step back. Let me first talk about the main method here. Remember, this is a chat client that I've created. All right, OBS slows down my system sometimes, but let's focus on what we have. Once I run this, I essentially run the main method. I have basically created memory object. It's a list object. We will store all the conversations here, both that is the input that I'm sending and also the responses that the server is sending, right? That's what I want to do. Okay, so simple chat agent. Hello, how can I assist you today? Once I run this, this is the question that it asks. And, essentially, we'll be using the SSE ops, and we'll send it two things, the user input and the memory, right, as context. So let me take you through the SSE ops. Everything is same here. We're essentially initializing the session and getting the list of tools, sending the list of tools and the memory and the query to get the prompt. The prompt is same. From the last time, we are getting the response from the LLM. It is essentially deciding which tool to be used, and then we could call the call tool method, right? Super simple. Everything is super simple. All right, and then a little bit of processing here to. Okay, I think this is the new part here, right? Obviously, this is a chat application, right? I can't simply take the tool output and then work with that. I want the tool output to have a little more context. And if some information is missing, I want to be able to communicate with the chat client, and the uh, the 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 LLM will essentially use the tools to its advantage and solve the tasks one by one. Okay, so this is where for that little bit of processing, this another LLM call comes into picture. So I'm calling this prompt as get prompt to process tool response, right? I have already got the tool response as you've seen, but this is the prompt that I'm using to essentially process the response that I have got from a tool. So the prompt is very simple. You are a helpful assistant. Your job is to decide whether to respond directly to the user or continue processing using additional tools based on the user's query, the tool's response in the conversation context. Think of this as the reasoning loop in an agent where depending on the conversation history and the tools that it has access to and the original query from the user, it is essentially making decision of whether it should basically send the response to the UI or the chat UI here, or process further and then essentially solve the tasks one by one. Okay. Uh, yeah, that's all there is to it, guys. And let me quickly run this particular client now. So I'm in the same directory. I'm going to say Python MCP client SSE underscore chat dot py. I hope it works. Tested this obviously. All right, so the chat has started. Let me see if it was able to. Oh, I think that particular command hasn't run because I think I've written this as the first statement. After I give the input is where it will start, essentially, you know, connecting to the SSE server. Okay. So how can I assist you today? You can ignore this because I used the query from the last time. I'm going to give it a new query. So I want to know what is the current time and weather in Bengaluru. Okay, so there, if you look at this question or query carefully, these are two tasks. One, it needs to get the time, and it also needs to get the weather for Bengaluru. And we know that we have both the tools available for us. So let's see how the LLM solves, or the chat agent essentially solves this. So I pressed enter, and the processing has started. All right, so it was able to establish a connection, and an LLM call was made. I think it is waiting for the response for the LLM. Okay, so there is an issue that we have run into. Okay, there is a connection error. Okay, I think I know what the problem is. Let me fix that. All right, so sorry guys, I'm just gonna clear this and we'll start this again. So we have established this. I'm gonna run the chat client again. Let's look at this in a bit. All right, hello, how can I assist you today? So what is the time and weather like? No, What is the weather? Right. What is the time? And sorry, this is tell me the time and current weather in Bengaluru. Sorry for the poor grammar, but I just want to test the LLM. All right, so a call was made and context was passed. It has understood its assignment. I'm hoping it works. Okay. All right. The response is, I'll come back to the response in a bit, but let's look at what it tried doing. Okay. It was able to obviously establish that connection with the SSE server. It's still running, as you can see. And it has two tools at its disposal. One is the time tool, and the other one is the weather tool that it got right. And printing tool identification prompt. So this is the tool identification prompt to the LLM. The LLM prompt looks something like this. We've seen that. So I'm going to go to the part where the LLM is doing its job. So the response from the LLM looks something like this. It identified the right tool. First, it is considering what it has broken down the query into two parts, or there are two tasks to the query, right? It needs to get the time and as well as the weather in Bengaluru. So let me go back to the response. The response from the LLM is tool time, and the argument is input time Asia Kolkata perfect. So it has rightly identified the tool and the arguments. And let's see if it was able to call the tool. So it was actually able to call the tool as well. And the response from the tool is the current time is, this is the current time in Bengaluru, and tell me the time and current weather in Bengaluru. This is the original query, and connected. So what it has done is it has identified that it needs to basically get the weather now, and it is essentially it has made a connection with the server again, and this time it is basically uses question, the current time is this, however I still need to look up the current weather in Bengaluru, please hold on, if no tool is required reply directly. Okay, so let's see what it has identified. It has identified the weather tool, and it is now processing that particular request. So users queries, however I still need to look up, this was the user's query response, the weather in Bengaluru is currently broken clouds with temperature of this. So the final response, the weather in Bengaluru is currently broken clouds with a temperature of 26.2 degrees centigrade. What I'll tell you something here. It was actually able to identify two tasks well, but what I see it has not done well is basically compose the final response, and and compose it in such a way that it is combining the responses of both tasks, which it hasn't done. It has only given me the response of the second task. Let me ask it, what about time? Okay, let me see if it identifies that I'm still asking the time for Bengaluru, and it has a response, and I think I should get the output. The current time is this. The weather in Bengaluru is currently broken clouds with temperature of 26.02 degrees centigrade. That's it, guys. That's all there is to this. You can actually build your custom clients and work with SSE, the server-side events. Very simple to establish. Now imagine that you are actually building a chat application. You can simply add these multiple SSE servers. Let's say that you are trying to solve for automation problems, and you're building workflow automations. You can, and if you have access to those APIs through an MCP server, then you can actually work with those APIs using a custom client like a chatbot, or use Cursor or any other MCP MCP client ready hosts and tools, right? All right, so I actually want to show you one more implementation that I did. Let me show you this particular part. I have implemented one more part, but we will save that for the next video. What essentially I have done here is I have implemented a simple chat client that uses both, or it has two servers. One is, let me actually quickly show you that. It is using both servers that we created. It is using the STDIO server MCP server that we created, that is the BMI server, and it is also using the SSE server. So we've made this client or a chat client that has connected with two MCP servers, and it will be able, depending on the context and the query, it will leverage the relevant time. But that would be in the next video. I'm going to do a quick walkthrough of that. Thank you so much for watching this video. I hope you like this explanation. If you like what I just shared, please like and share this video. And if you haven't subscribed already, please do subscribe. Thank you so much for watching. Have a good one. Bye.